Hey guys, it's Mr. Lowry here. This is for Monday, 11:16 if you're in cohort A, or Tuesday, 11:17 if you're in cohort B. Today in class, we are still kind of gathering some information, just building a foundation to help us get to the point where we're ready to start writing proofs. I gave a couple handouts today, and I want to kind of talk through each one of them and just kind of give you a kind of a rundown of what we talked about, and you can read some of these on your own. Okay, the first handout that I gave out today was this types of proofs. Okay, so there's several pages here. A lot of these are like images, and so they take up a lot of space. I'm not going to read through this whole thing with you. You can do that on your own. And some of these ideas we've talked about already. But the first page here is the building blocks of proofs. We're going to come back to this in just a minute. This is some good information here, but before we do that, I want to take a look at the second page, which just says, what is a proof? There's a couple things that I think are kind of important here. The first is this idea. So a proof is a logical argument that establishes the truth of a statement. Okay, sometimes in math we wonder, why do we have to learn proofs, or why do we have to study proofs? The whole idea is this idea of being able to create a logical argument. Okay, in the second paragraph there's some key ideas here as well. The process of building a proof, it requires critical thinking, logical reasoning, and disciplined organization. And so that's what we're practicing here. When we practice these skills, when we practice proofs, we're developing these skills and helping our deductive reasoning to develop. Now this next section here just talks about the formats of proofs, and there are a couple different ways of looking at them. Let's look at this one that you're probably most familiar with. Okay, this is called a two-column proof, and I just want to point out a few things here. Okay, in a two-column proof, you have two columns. Obviously, that's why it's called it. On the left, you have statements, and the statements are basically the steps of your proof. And then on the right, we have reasons, and these are justifications. Okay, so for each step that we take, we want to be able to give a reason or justification why that step makes sense. In this example here, we have this given information. C is the midpoint of AD. C is the midpoint of BE. That's based off this figure. Okay, when we start a two-column proof, we always start with the given statement. So notice that this guy is right here, and the second given is right here, and the justification for that is just right here. Okay, that's kind of how any two-column proof starts, with the given information. From there, many times you want to say, well, what does that mean to me? What deductive step can I take from this to get another step? Okay, now we talked about midpoint before. If C is the midpoint of AD, then that means that this segment AC is congruent to this segment CD. If C is the midpoint of BE, this is halfway in between B and E, then that means BC is congruent to EC. So we can kind of label these guys congruent here. And that's basically what happens in step 2. BC, this segment, is congruent to EC, this segment. Okay, AC is congruent to DC. And how do we know that? Well, this piece of information. A midpoint of a segment divides the segment into two congruent segments. Okay, now that's actually kind of the definition of a midpoint, but also in your book, there's a theorem that's called the midpoint theorem. So this guy right here is a theorem. Okay, it's called the midpoint theorem. All right, now from there, we see that these two angles ACB and DCE, this guy and this guy right here, these are vertical angles. Okay, there's another theorem that we haven't talked about it in this class just yet, but you probably visited it last year, is the vertical angles theorem. So that's this idea. Vertical angles are congruent. Okay, it states that in words, but you could just kind of say this theorem here. Okay, so now we have these two triangles here, and we want to prove that these two triangles are congruent. Okay, we want to show that triangle ABC is congruent to DEC. And there's one more theorem that we need to use here, and that's this SAS theorem. Okay, you might have heard of this theorem before. It's called the side angle side theorem. If you have two sides of a triangle and their included angle congruent, then you can conclude that the triangles themselves are congruent. So since I have this side congruent to this side congruent to this angle congruent to this angle, I can use this side angle side congruence theorem to say that this whole triangle is congruent to this whole triangle. So this is the side, angle, side, congruence theorem. Okay, now you may not be able to like reproduce that proof all on your own just yet. That's okay. The main thing I wanted to point out here is that these reasons or justifications, there's only a few different kinds of things that you can use over here. Okay, one of the things you can use is theorem. So notice I have theorem, theorem, theorem. Right, so all these guys pretty much are theorems in this case. If you're wondering what can I use over here in these reasons, we can kind of go back to the first page here and look at the building blocks of proofs. So in this case, it says, or in this page, it says you will see definitions, postulates, and theorems used as primary justifications appearing in the reasons column. Okay, so what this is telling you, this first page here, is what can we use as a justification? What are some of the ideas that we can use? Okay, well, definition is one of them. And we've done a ton of these definitions, right? We've talked about angle and segment and midpoint and angle bisector and congruence, congruent segments, congruent angles. So we have a bunch of these definitions we can call upon. Okay, we got postulates. So there's postulates in the book, which I'll point out to you in just a second. Also, we talked about Euclid's postulates. Euclid had 5 ideas, 5 postulates that he started with as building blocks to kind of create new theorems. Okay, then we have theorem. Okay, theorem is a statement that's been proven true already. So if a statement has been proven, theorem, we can use a theorem in a proof as well. Okay, we're also going to talk about properties here. Properties of real numbers are good. We're going to spend some time discussing these today. And there's one other thing that I would add here in addition to these 4, and that is a construction. Okay, a construction is like usually a line that we add in a proof to add to a diagram to make it a little bit easier to prove. So a construction is something we add to a figure to make a proof easier. Okay. Some examples of that we can do are like an angle bisector, or what we call a median, or an altitude. We can have a perpendicular bisector. These are all things that we're going to talk about in the future a little bit more and how that looks on a figure. But I just wanted to kind of set the stage for you that constructions are also sometimes things that we can use in our proof. We can add an extra piece. Let me give you a quick example. Let's say I had a triangle here and I wanted to prove that this angle was congruent to this angle. Okay. What I might want to do at some point is drop a line from this angle that goes down the middle of this triangle and say, okay, I'm going to call this a perpendicular bisector. Okay, that's one way that you could add a piece of information here. So there's different kinds of things we can add, bisectors, altitudes, medians, to our figures to help us finish the proof. But these are the main 5 categories of things that we're going to use as justifications in our proofs. So going back to this guy right here, this 2-column proof. Okay, the things that can go over here, generally speaking, are definitions, theorems, postulates, properties, and constructions. So it can't just be anything. It has to be something that we've already kind of established or proven, or something that we already have to draw upon. Now what we did in class here, I'm going to let you guys do this on your own at home, but we looked at this other kinds of proofs. Okay, so there's a paragraph proof. We have a flow proof. And we have a transformational proof. Okay, all these proofs actually prove the same thing. So each one of these example proofs is this same proof here. So if you're at home, what you should do, this is what we did in class, is read through each one of these to get familiar with how it works. See if you can follow the reasoning here. And then you maybe write a quick, pro and con list. What do you like about the proof? What do you not like about it? Would you use it? Things like that. So we talked about, the paragraph proof is a little bit more detailed, which is great if you're reading it, a little more explanation, but also it's a little bit less structured than the 2-column proof. Okay, the flow proof is a little more visual, so that's kind of an advantage here. It's a little less writing. So go through those different types of proofs. Again, read through the description and then see if you can follow the proof and see if it makes sense to you. And then just jot some notes down about that. So that is the first handout. It's about types of proofs, setting up a proof, and kind of the structure of proofs. You can get this as a PDF from Canvas and just print that off and put it in your notebook. Add any notes that you might want to make about that. All right. Next, I just wanted to go through your book a little bit and just show you how some things are set up, okay? All right, so this is section 2.5 or 2-5, okay? We're going to kind of breeze through some of this, but I just want to point some things out. Okay, in section 2.5, this is the first section of your textbook that actually starts talking about what a proof is and how to set up a proof. So it talks about postulates and axioms, which we've already defined, and it gives you your first few postulates. So these are not exactly the same as Euclid's 5 postulates, but they're very similar. For example, through any 2 points, there's exactly 1 line. Okay, that's something that we can use in our proof. Okay, on the next page, we have more postulates about lines and planes and points and things like that. Okay, so these are all different ideas, key ideas, basic ideas that we can use in proofs. Okay, midpoint theorem. If M is the midpoint of AB, then AM is equal to AM segment is congruent to MB. Okay, so in this case here, we got a segment and M is the midpoint. And so we can say that this segment is congruent to this segment, if that's the midpoint. That's the midpoint theorem. Kind of talked about that a little bit already. So that's just a really quick introduction to what a proof is and some of the basic postulates. Okay. Now I showed you guys, if you were in class, if you weren't in class, then this is good for you to know. In the back of the book here, towards the end, there's a section that has a purple edge, and it gives you all your theorems and postulates. Okay. So I'm going to show you that really quick. It's kind of small, kind of hard to find. All right. So this right here has all the same information as the inside of the textbook. It's just shorter. So notice I showed you where the first postulates were. Here's all the first postulates and the midpoint theorem. So 2.1, 2.2, 2.3, 2.4, right, all the way down to midpoint theorem. All this stuff is in your book, but this is a quick reference to it. So in the back of your book, at the purple edge of your page, that's where you're gonna find your postulates and theorems. Sorry, my lights turned off. I had to get up and turn them back on. All right, so this is kind of where your axiomatic system here starts. Now, notice here, when you start having your theorems, we start proving these theorems like, let's say the vertical angle theorem, for example, way down here. Okay, if you wanted to prove the vertical angle theorem, you can use theorem 2.7, 2.6, 2.5, anything that comes before it, you're allowed to use to prove this guy. But you wouldn't want to use theorem 2.9 or 2.10 because those come after the vertical angles theorem in the book. So this kind of goes in order of how you would normally prove them. We're not going to go through and prove every single theorem here, but we will prove some of them. So if you're wondering, what can I use to prove this is true? Well, everything you can use for this is basically before it. It's all back up here. Any of these are your tools to prove. Okay. The next section here is about algebraic proof, and we're not going to do a ton of these, but I did want to point out this. Okay, these are properties of equality for real numbers that we talked about at the beginning of class. at the beginning of the school year, excuse me. So we talked about reflexive, symmetric, and transitive. Those are properties of equality. Also the addition and subtraction properties, multiplication and division properties, substitution, and distributive property. These four right here are often used when we solve equations. So this one, for example, says if you have an equation, you can add the same thing to both sides and it's still true. This is just a symbolic way of saying that. We use that a lot when we're solving equations. Add the same thing to both sides, subtract the same thing from both sides, multiply both sides by the same thing, divide both sides by the same thing. Those are all things we use when we solve. So that's going to kind of come into play. All right, and then the next section, we talk about proving segment relationships. So this is where we're headed. This is where we're trying to get to, and where we kind of got towards the end of class today. All right, so a couple things to keep in mind here is we have some segment congruence properties, which I'll talk about in just a second. And another thing that's really important here is this segment addition postulate. Okay, the segment addition postulate basically says when you have a segment and you have two segments making up that big segment, the measurement of the two small segments added together is the measurement of the long segment. So here it says AB plus BC equals AC, right? So here's AB plus BC, that's going to be equal to AC. That's the segment addition postulate. Okay. One thing I want to point out to you here that's kind of important, this is another handout that I've made, is there's a big difference between congruence and equality. Okay, so this is a handout that I made, also available in Canvas here for you to print out and put in your notebook. I took these from the book, okay, but on the left column you have properties of congruence, and on the right-hand column you have properties of equality. Okay, the difference here, so for congruence we have this reflexive property, symmetric property, and transitive property. We also have reflexive, symmetric, and transitive here for equality. Okay, so they have some things in common. This is congruence for segments, this is congruence for angles, and here is equality. So we have two different sides here, congruence and equality. The difference here is on equality, we have these extra ones. So just a second ago, I pointed out properties of equality, these guys right here. Notice we don't have those for properties of congruence. Okay, so a couple key ideas here. First off, congruence and equality both have reflexive, symmetric, and transitive properties. So all three of them have these three. You can see those here and here. There are more properties of equality than there are properties of congruence. So we got all these extra stuff, this stuff over here. Okay, these properties, addition, subtraction, multiplication, division, substitution, and distribution, these are all properties we use when we're solving equations. There are properties for manipulating things algebraically, rearranging equations and stuff like that. Zoom in here a little bit. You have a copy of this here, so if you can't quite read this or if it's a little small, you can look at the copy that I've provided on Canvas. Okay, oftentimes we want to be able to use these properties in a proof, okay? And in order to do that, we have to switch from a congruent statement to an equality statement. So if we're given a congruent statement like this, for example, this is saying two segments are congruent. Sometimes we have to translate it over into an equality statement, because with an equality statement we can use addition, subtraction, multiplication, division, substitution, distribution. All of our algebraic tools we can use on this, but we can't use on this because this is not equality. Same thing for angles. Sometimes in a proof we're given some angles and we want to be able to do some algebra stuff on them, but we can't do it in this form. This is a congruent statement. We have to change it into an equality statement where we have an equal sign and measurements. Once we have it in here, then we can use these different properties of equality. So this xy is the measurement of segment xy. AB without the line on top, that's the measurement of segment AB. Okay, measure of angle A is the measurement, obviously, of angle A. So the notation is a little different. This has a line on top, this doesn't. Okay, this is talking about a segment, this is talking about a measurement of a segment. Okay, congruent to, equal to. Again, this is talking about a segment, this is talking about the measurement of that segment. So this represents a number, this is representing a shape. For angles, same thing. This represents an angle. If you want to talk about the measurement of that angle, you need to put a little m in front of it. Okay, this has a congruent symbol, this has an equal symbol. Okay, and then again, m in front of the angle. This is talking about an angle. This is talking about the measurement of that angle. The reason why that's important, again, is because in equality, we can use 4 more properties of equality. We can use all this algebra stuff. So in just a second, we're going to do a couple algebra proofs, and I'm going to show you how translating between congruence and equality can help us to finish these proofs.